Hello and welcome to our lesson 10.8 notes for spheres. Our objectives will be to learn and apply the formula for the volume of a sphere and to learn and apply the formula for the surface area of a sphere. So we're going to begin by working out these warm-up problems. I'm going to let you go ahead and do that and then we'll check our answers all together. So make sure you pause the video to give yourself enough time to do the warm-up if you have not done so already. When you are ready, click play to continue. And these are the results we should get. Number 1, our radius is 12.5 centimeters. Number 2, the circumference is 85 pi inches. Number 3, the area is 169 pi square feet. And number 4, the circumference is 50 pi centimeters. All right, let's take a look at our lesson about spheres. Now, you may remember the definition of a sphere, but here is that official definition. It's the locus of points in space that are a fixed distance from the given point that we call the center of a sphere. And a radius of a sphere connects that center to any point on the sphere. A hemisphere is half of a sphere, and a great circle is a circle that divides a sphere into two hemispheres. So we have our center here. This could be our radius. This is our great circle. Think of the equator of the Earth. That's a great circle. And then half of that sphere is called a hemisphere. We have a formula for the volume of a sphere given as 4/3 pi r cubed. And we'll talk a little bit more about that formula later, but for right now, just remember this is your formula for volume. So we can go ahead and use that formula to find volume of spheres. So number 1, we're going to use that volume formula. Volume equals 4/3 pi r cubed, not squared. And we're going to find the volume of these different spheres, or in this case a hemisphere, for example, 1c. So for number 1, we need to find the volume of this sphere, giving our answers in terms of pi. Well, if the diameter is 24, we know the radius then is half that, or 12. So I'm going to let you use the radius of 12 and find the volume of that first sphere using that formula. All right, this is what we should get. Our volume is 4/3 pi times our radius of 12 to the third power. When we take 12 to the third power, multiply by 4, and divide by 3, our volume works out to be 2,304 pi cubic inches. All right. On part B, we are to find the diameter with a given volume. Remember, diameter is twice the radius. So if we can find the radius, we're just going to double it to find the diameter. And that's what we should do because they give me the actual volume of the sphere. So I'm going to start off with the formula. V equals 4/3 pi r cubed. And we're going to plug in what we know. We know that volume is 36,000 pi. So we're going to replace V with 36,000 pi. So our formula now reads 36,000 pi equals 4/3 pi r cubed. Now the idea is to get r cubed by itself. And so here's what we're going to do. We're going to multiply both sides by 3/4 pi so that we can divide by 4 on both sides, divide by pi on both sides, and multiply by 3. So we're going to multiply both sides by 3/4 pi. That'll cancel these and these. On the left side, the pi's cancel, and we just need to multiply 36,000 by 3 and divide by 4, or divide by 4 first and then multiply by 3. And when we do, we get that r is 27,000. I'm sorry, r cubed is 27,000. That means r times r times r is 27,000. Now, the easiest way to do this is to use your calculator and take what is called the cubed root. Not the square root. We're taking the cubed root to undo r cubed. And here's how you're going to use your calculator to do that. You're going to need to find a button on your calculator that has something that looks like this. Looks like the radical symbol with a little x up to the top left. Some of you actually have a cubed root button that you could actually use, but for the most part, we're going to use this. On my calculator, I need to actually hit the little 3 before I hit that button. So in order to do this problem, I'm going to type in 3 to set up the cubed root. I hit second, and then this button right here. If I hit my second or function button, it brings up the cubed root. since I put the 3 first. Then I put in my 27,000. Hit enter, and we get that the cubed root of 27,000 is 30. That means 30 to the third power is what would give me 27,000. Now we could use guess and check, but it's a lot easier to use 30. So the radius of our sphere is 30, so the diameter is twice that, or 60 centimeters. All right, let's try part 1C, finding the volume of a hemisphere. This is going to be a lot more like part A, but we only want a hemisphere. Well, a hemisphere is half of a sphere, so all we have to do is find our volume and take half of that. So if I want to start with my formula, the volume of a hemisphere is just half the volume of a sphere. So I set it up like this, 4/3 pi r cubed, and then I want half of that. Well, I can do some cross-canceling here with the 4 and the 2. So the volume of a hemisphere, we could say, is 2/3 pi r cubed. And so we're going to use that formula in solving this. So you were given the radius is 15, so why don't you go ahead and plug that in, find your volume in cubic meters, and then check your answer. Pause the video if you need more time. All right, this is what we should get. When we take 15 cubed times 2/3 pi, we get 2,250 pi cubic meters. All right, we're going to go ahead and take a look at our application and kind of go through this quickly, and we'll go over some questions if we have them, but I'm going to make it a lot easier for you to understand. Sporting Goods store sells exercise balls in 2 sizes, Standard, which has a 22-inch diameter, and Jumbo, which has a 34-inch diameter. How many times as great is the volume of the Jumbo ball as the volume of the Standard ball? Well, here's what we're going to find. Volume of the Jumbo and volume of Standard, and we're going to compare those two. Jumbo being larger than the standard size. So we're going to look at what would we multiply standard by to get our jumbo size ball. So really all we have to do is divide these two. This size divided by this side will be our answer. So I want you to find the volume of each one. The standard size ball has a diameter of 22, so the radius is 11. 34-inch diameter for the jumbo would mean the radius is 17. So you're going to use those two radii to find each individual volume using this formula. Volume equals 4/3 pi r cubed. So find the volume of the jumbo using r is 17, and the volume of the standard using r is 11, and we're going to compare those two. So pause the video so you have enough time to complete that part, and then we will come together to find our final answer. Okay, we should get the following individual volumes for jumbo size and standard size. For the jumbo size, you get 6,550.6 repeating. For the standard size, you get 1,774.6 repeating. Those are both in terms of pi. Again, I have not multiplied by pi yet. I did everything but times pi, because we don't need to. To find out that ratio, we're going to take the larger one and divide it by the smaller one. And so when it says 0.6 repeating, you can just hit as many 6s as your calculator screen will allow. Same thing for both, and then do that division. We don't need to worry about the pi. Pi's will cancel. So we're just taking this number divided by this number. And in doing so, we should get the ratio of these two is about 3.7 times as great, or as large. Now let's take a look at surface area of spheres. We're given this formula in our text. Surface area of a sphere is 4 times pi r squared. You'll recognize pi r squared is the area of a circle. And so our surface area incorporates that area of a sphere. So let's take that formula and go ahead and work out some examples using surface area formula of a sphere. Remember, the surface area is 4 pi r squared. So you guys should be able to find part A on your own. I'm going to let you do that and we'll check our answers because they give you a diameter. Remember, that's twice the radius. So first you need to find the radius. Go ahead and pause the video, give yourself some time to work that out and check your answer. Alright, if you need more time, pause the video, but otherwise we will check our answer and we should get this. If the radius is 38, because the diameter is 76, then 4 times pi times 38 squared is about, or it is exactly 5,776 pi square centimeters. Alright, let's take a look at part B. we are to find the volume of a sphere with a given surface area. So we're going to use this formula to find the radius and then plug it into our volume formula. Remember, volume is 4/3 pi r cubed. So we're going to use that formula after we found our surface area, or after we've used our surface area to find the radius. Once again, surface area is 4 pi r squared. So we're going to plug in our 324 pi for s. Set that equal to 4 pi r squared and solve this equation for r. The first step is to divide by 4 pi. When we do 324 divided by 4, we get 81 and the pi's cancel. So our radius squared is 81. So we need to take the square root of both sides. You should be able to see that then the radius is 9. Now that we know the radius is 9, we plug into this formula to find volume. 4/3 pi times that radius of 9 cubed. In terms of pi, after we multiply all that out, we should get that the volume is 972 pi cubic inches. All right, so let's take a look at part C. We are to find the surface area of a sphere where we are given a great circle that has an area of 49 pi. Well, if this great circle has an area of 49 pi, we also need to recognize the great circle has the same radius as the sphere. So if I can solve this for my radius of my great circle, I can use that radius to find the surface area of a sphere. So remember, area of a circle is pi r squared. So if that equals our area of 49 pi, we just solve for r. And if r squared is 49, then r is 7 inches. And we use that radius to plug in to find the surface area of the sphere. In doing so, surface area, when you plug it into this formula, should give you 196 pi square inches. All right, let's quickly take a look at exploring the effects of changing dimensions. If we're talking about volume of a sphere, then we simply take the amount that we're changing the radius by, because the radius applies to all 3 dimensions of our sphere, and we cube that factor of change. So if the radius is multiplied by 3/4, then the volume is multiplied by 3/4 cubed, or in this case, 27 over 64. Okay, our volume would be multiplied by 27 over 64. All right, last little bit of our examples here incorporates finding the surface area and volumes of composite figures. We're only going to do part A. We'll leave part B to be either be done in class, or you can do it on your own if you would like. But we're going to go ahead and take a look at part A. Now, let's find surface area first. Surface area is going to be comprised of the surface of a hemisphere plus the lateral area of a cylinder plus the base area of a cylinder. So we have our surface area of a hemisphere plus the lateral area of a cylinder plus the base area of a cylinder. Okay, surface area of a hemisphere is just half the area of a sphere, 4 pi r squared. So the surface area of a hemisphere is half of 4, or 2 pi r squared. The lateral area of a cylinder is 2 pi r h, and the base area of your cylinder is just the area of a circle, pi r squared. So let's fill in what we know. The radius of your hemisphere and cylinder is half of 12 is 6. Okay, so I'm going to do 2 pi times 6 squared plus 2 pi times 6 times the height of your cylinder, which is 9, plus pi times 6 squared. So I'm going to allow you to do all those calculations and get a final answer in terms of pi for surface area. All right, we should get 216 pi square inches for surface area. Now for volume, we're going to take the volume of our cylinder plus the volume of a hemisphere. In doing so, we get 468 pi cubic